Today we are going to talk about utility, marginal utility, and marginal rate of substitution. Okay, so this is the indifference curve. Here we have the good x and here we have the good y. So this is the indifference curve, and we can find the marginal rate of substitution by calculating the slope of the tangent line. I hope you remember, but the tangent line is this kind of line you have following the curve. You see all those different lines. And you can see that the slope will be different according to where we are on the graph. So if we want to calculate the slope of the tangent line, of the line between the point A and the point B, we need to calculate the difference here, so delta y over delta x. So the marginal rate of substitution between A and B, so let's do this, A and B. So delta y, we have 50 minus 40, so over delta x, and delta x, so 20 minus 30. Okay, and this is 20 over minus 10, so it's minus 2. So what does marginal rate of substitution equal to minus 2 mean? So the minus 2 here means that when I move from point A to point B, I give up 2 good y in order to get 1 x. And now if, for example, we want to calculate the marginal rate of substitution in a different position, let's say between point B and point C, we will have different numbers because the slope is not the same. So for example, let's say here it's 10 and here it's 15, and the result will be, for example, marginal rate of substitution equal to minus 1. So moving from B to C, you give up 1 y in order to get 1 x. So the marginal rate of substitution can change. And this is called the diminishing rate of marginal rate of substitution. So as we have seen, the marginal rate of substitution is the change in y over the change in x. And if we choose like two points very close one to another, then the marginal rate of substitution, the slope of the tangent line, is the first derivative of the indifference curve. Something very important about utility is that the utility along the indifference curve is constant. This means that along the indifference curve, the change in utility is equal to 0. I'm going to show you how it works. For example, let's say we are here. So utility x1, y1, and let's say here, utility x2, y2. And this is equal because along the indifference curve, you have the same utility, like the same level of happiness everywhere on this curve. So we can write this. So you have the utility at point 1, so utility x1, y1 is equal to utility at point 2, x2, y2. And if you subtract utility of point 2 from each side, you have the utility of point 1 minus the utility of point 2, so the change in utility is equal to 0. So this is what we want to demonstrate, that the change in utility is 0. This letter is a Greek letter and it means change. So the change in utility due to a change in the consumption, so you can consume more or less, a change in the consumption of good x is this. Change in utility of the function x, y, over change in the consumption of x. And this, the change in utility due to a change in the consumption of good x, this is the marginal utility of x. So we have marginal utility of x is equal to change in utility x, y, over change of x. This is the marginal utility of x. And for y is exactly the same thing. You can say the change in utility due to a change in the consumption of good y, is equal to the change in utility function over the change in consumption of good y. Now I'm going to demonstrate how we find that the marginal rate of substitution is equal to the change in y over the change in x. So, change in utility is equal to change in utility regarding change in consumption of good x regarding x, so dx, plus change in utility over change in consumption of good y regarding good y. And we know that the change in utility is equal to 0. All of this needs to be equal to 0. So now I'm going to subtract this part from each side. So we are going to have this change in u. And every time I am writing change in the utility function, I should be writing this, because the utility function it has two variables, the x and y. So this over this dx is equal to minus over, I'm going to divide by dx from each side. So here it's going to, and here I'm going to have, oh, I forgot. So here I'm going to, this one went out, and here it's going to be like this, over dx. Now let's continue. And before we have seen that this was equal to the marginal utility of x. So we can replace it. Marginal utility of x equals to minus marginal utility of y, dy over dx. Now I am going to divide by a marginal utility of y each side. So this is going to go up, and here divided by marginal utility of y. So now I'm going to rewrite it, marginal utility of x over marginal utility of y equal minus, okay, and this is the same thing as delta y over delta x, and as we have seen before, this is our marginal rate of substitution. Ta-da! So we have the ratio of the two marginal utilities equals the marginal rate of substitution. And it's a minus because the slope is negative, but you don't really care about the minus, okay? So now I'm going to explain this with an example. I wrote there what we have found before, and now let's take, for example, the Cobb-Douglas equation for the utility function. So this is the equation. First step, we want to find the marginal utility for good x. So to find the marginal utility regarding good x, we need to derivate this utility function with respect to x. So let's do this together. You know that when you want to derivate something, the derivative of this function regarding x is this. You put the a here, a times x to the power a minus 1, and this part don't change because you don't have any x, so it's still the same, y to the power b. Second step, we do the same thing regarding y. So this time the x power a don't change, and now you put the b here, so b times y to the power b minus 1. So now we have our two marginal utilities, and we are going to be able to find the marginal rate of substitution by dividing this one by this one. So let's do this. Third step. So the marginal rate of substitution is equal to this over x power a times b y b minus 1. This is equal to, and this is equal to a times y over x times b. And that's it. We have done it here with letters, but if you have a number in an exercise, it's going to be exactly the same thing. What you need to remember is, given a utility function, you need to be able to find the marginal utility regarding x, then the marginal utility regarding y, and when you have found those two marginal utilities, you are going to be able to find the marginal rate of substitution. So now if you want, you can quit this video because I am done about this subject, but I'm just going to explain how to find this result with this equation, because I know it can be a little bit complicated. So this is what we found before, and we need to go to the result y times a over x times b. So how to find this? You need to separate this calculation in different parts. So we are going to calculate first this ratio of x power a minus 1 over x power a, and after we are going to calculate this one, y to the power b over y to the power b minus 1. So you need to remember this formula. 1 over x is equal to x power minus 1. And from this you will be able to find the result. So let's do this together. This first part. So we have x power a minus 1 over x to the power a. If we want to change a little bit this, you have x to the power a minus 1 times, it's the same as this, 1 over x power to the power a. And as we have seen here, this is the same thing as x to the power minus a. So now we are going to have x to the power a minus 1 times, and we put this x to the power minus a. And now this is something you need to know. We'll continue. When you have a number with a power times a number with another power, you can sum the two powers. So we have x to the power a minus 1 minus a. So a minus 1 minus a goes out, and x to the power minus 1 is 1 over x. Okay, so from this we have 1 over x. So we can start rewriting this here. And now we have a over x. And now we are going to continue because we simplified this part, and this a is going to stay there, and now we need to take care of the second part. But basically it's going to be the same thing. I'm going to write it here. So we have y power b over y power b minus 1. We want to rewrite it. So we are going to have y to the power b times y to the power minus b plus 1, because you are going to do minus b minus 1 and it's going to change the sign. And this is equal to y to the power b minus b plus 1. So the two b's are going out, and we have y to the power 1, and this is y. So now we can put this here again. All of this is equal to y. So we have a times y and x times b, because we haven't taken care of the b. And that's it. We have the result. So thank you for watching this video, and see you soon.